Hello everyone, this is Build PKG and today I'll be trying to explain this stun protocol. And actually, our last video was about WebRTC, and WebRTC completely kind of depend on this protocol to work. Not completely, but in some way it does depend on it to work properly, like the best. So what this stun protocol does is, I will actually try to make a stun request through netcat and show you how it does work on Wireshark, and I'll do a netcat request up here. So this is the stun protocol. So what it is used for is, suppose, okay, take this picture as a reference. Suppose there is a NAT. This is you as a stun client. Okay, you are a stun client and you are behind couple of NATs. There is a private NAT, there is a public NAT, and there is a public internet. So what you want is, you want to know what you look like on this public internet, like whatever request is going through this NAT to this guy, what it does, this server is, server looks like, server is able to see you as, in simple words, like what you look like there in this public internet. So somehow, if you know a little bit about the NAT, they actually assign you some IP address and port for your requests for some temporary amount of time, and within that time, if you just make requests and get to the server can respond you on that IP address and port, and that actually get translated and just comes back to you. So if you are actually under the NAT and you start some kind of port or something like that yourself, it won't be opened on this and mapped like that. So it will never, you cannot like open a public port, like public internet port outside NAT straightforward. To tackle this situation, we have something called as stun. Stun is, if you actually read this RFC, you will get to know that there was one more stun protocol in 3489. This is 5489. Okay. When here I can show. Yeah, up here, see, up top. 5389. Sorry. This is 5389 and this is 3489. Okay, so older one has so many problem and it was supposed to be a good one, but it only worked with some kind of NAT, but not all kind of NAT. It didn't had a way to figure out if NAT will work or not. Okay, to handle this situation, they came up with a new stun, and they said that this is not actually a solution for NATs, like NAT hole punching. You can actually use it as a tool to get the work done, as a tool. Don't see as the whole solution for it. So uh we need to know one more thing, that is NATs are of three types. One is that, like, three types. The first one is, if, like, for example, my request goes up here, then it gonna map a IP address and port for me. Okay, so if the NAT allows any other user, no other than this server on this public internet, to make a communication through this assigned IP address and port on this temporary assigned IP address and port on this network, allows a communication, that is open NAT. If it gonna restrict, like check for the IP address to be same as of the stun, then it is address restricted. And if it gonna actually match the port to IP address and port both, in that case, that is actually a IP address and port restricted map, NAT. So what is the problem is that in both of other cases, it's kind of difficult to get a NAT, get a something like stun. But in the first case, when you can actually get some request from other party, this will work. So modern NAT actually gives some of the solutions to get the IP address and the port. Then you can perform a series of tests to know if it is working for you. So what we are interested uh, today is this package structure, because I want to let you see what you look like on your public internet. It doesn't matter which kind of net you are behind, which kind of net. You can actually see what the stun server look see you as. Okay. But the thing is, maybe you won't be able to communicate with a new client, maybe some other server or something like that. So let's look at the package structure. I know, like, maybe my viewers won't be very comfortable with this, but we'll try to get it very slow. So, first of all, if you see this structure, there is one strip up here, one strip up here, and a big one. The size for this one is already given. That is 96-bit, which is transaction ID. In short, I will actually explain it instead of just scrolling up and down. Anywhere I can read. Fine. So transaction ID is just a unique ID which will be identifying your request and response. Like, both will have the same transaction ID. That's it. Magic cookie is actually a fixed number. If anywhere I can get that number, I would. If I have seen somewhere in this RFC only, I took it from there, but I just forgot to mark it. Okay, I'll tell you what this magic number is, but for now it's okay. We will see. So this is the magic cookie, and this have to be a particular hexadecimal number, and then this is the length of the message, because this actually structure is message header. Like, there is a header, there would be a head of it, and there would be a body of. So the message length is actually the length of the body. For a simple request to know your IP address, you actually don't need to uh, give any body. So length of the message could be 0000. And then stun message type. If you see stun message type, it the first two are significant would be 0. The stun message type would be really this format. So if you can see, actually, if you can see, there is a 14-bit and 2-bit to make it 16. There is a padding. Okay, so this is actually 14-bit, and this will help you identify the type of request which you are making. And this is composed of actually two stuff. One is method and other one is class. Anywhere I can highlight that up here. Yeah. So actually you can see there are 4 classes. One is request, one is indication, one is success response, one is error response. Is straightforward. The word actually mean what it is. So we are actually interested in this one, to make a request. And then there are methods. The method which we are interested in is binding method. Actually, this RFC explains only binding method because it is only needed. So one more thing I'll try to make a note out of it is, you see there are like some length of this, maybe 12. Yeah, it is 12. Method is 12-bit long, and then the class is 2-bit long. So what we have to do is, if you see C M M M M M and M M M, this M M M are bit of method and C are bit of class. So you have to put your bit. For example, if you want to make a request that is 00, then you have to put first 0 here and the second 0, the second 0 up here. Simple. The first will go at the first, the second will go at the second. Simple as that. Then for the method also, according to the left to right, the way it is written, the same way, this is actually like that. So you have to straightforward write like it. The message structure is actually following a big Indian. Okay, so it is like left to right reading. So do it the natural way. Furthermore, then when it's done, it's good. You have the method, you have the length and everything, which I actually, if I get that, like, yeah, not this one, yeah, this one. So actually, I calculated that for me. So message type would be binary plus request. The class is 000. Method is something like this. The type would be this long bit. Bit binary, so you see B binary. So it can be converted to hex, which would be 0001. If you just to for the simplicity, if you just take 4 of it and see the hexadecimal number possible, then you can actually just simply convert it 4444, and the last 4 would be 1. Great. The message length is 0, so it would be 000. You may ask me why we have to put 4 zeros. You just see the size of it. It is around 16 bits. So you need to put 000. Then this is the magic cookie. It has to be fixed because you know what, we can actually use stun with different kind of protocol. For example, ice, you can use it with that to do some kind of filtering, like this is the only stun protocol. For that purpose you can use actually this magic cookie. Then there should be a transaction ID. We can take any random transaction ID. I don't know. While I was thinking about it, I thought maybe one. Then later on, I just put some random stuff and it works great for me. So that's the whole stuff. You can actually, yeah. So if you just, so I, up here, if you just look at this, this is 0001, 4 zeros, 4 zeros, 2, 1. The magic cookie is till 42 up here. The magic cookie is there, and then later on it's some random stuff. Now this is the stun IP address for Google, and this is its port for having, like, for checking what is the traffic going on. I will start this, then I'll make a request. You see there is some kind of output. uh, I should actually stop it. Great. If I stop it, there will be no more output, so we won't be very cluttered with what is up there and won't be very overwhelmed. So this is the binding request. You can see the source IP address is this, which is my IP address on NAT, and this is the destination which we gave. You can see there are different layers of networking. Ethernet, we are not interested in this, not in this. We might be interested in this user datagram, and then we might be interested in this. Great. Can you see? Actually, it does even know how to parse the request which we made. This one, this request, how to parse it. You see, message type is given, binding request, length is given, cookie is given, transaction ID, some random stuff, very random. To be honest, I just type it 245 like that. Okay, so that's random. Fine. So there is the cookie and everything is great. There is the source IP, source port for us, and there is the destination port. Uh, that's cool. That's cool. Then we go to the response, and you know what? Actually, I didn't tell about it. The body is actually divided into the attributes. The body is divided in attributes. There might be a structure for attribute in this. stern attributes. So there is the attribute. Okay, there is a type length value TLV. That's it. So up here, let me just get you through very simple stuff. So this is the destination port. Okay, this is a destination port. Great. This is the source port. Great. Everything is fine. Don't it this can be changed. This is based on what is inside the net and stuff. This is port. Don't get bothered about this because this actually keep changing based on your net. Your net is actually doing some translation in this layer only, the user datagram, which is transport. What we are interested in is this final STUN, stun, this final stun message. So just if you look at this cookies and stuff, transaction ID was same as what it was before. I don't want to match it, but yeah, it is same. You want to? I just get back to the video. You can just see. What I am really interested in is that it is. That's what it is. 57, sorry, 37511. That is the public port assigned by my NAT. And this is the my public IP address. Believe me or not, based on which kind of service provider you are using. I'm using a Geo service provider, so they actually restrict the NAT with port and IP address, the packet. I don't know. I did try to make the request, but that didn't work for me well. But I am able to figure out at least what I look like outside. Like very great sages once said, you need to know who you are. So this is what they mean. No. Well, the thing is that 152, something like that, something like that, something like that. This is finally my public IP address, and this is finally my public port. If my NAT allows me to just make a request from some other client and take a response on this PC, then it would really work. It would really work, and that is what that is what is called as TCP hole punching. We have actually already punched a hole. When we just make a request, we have already punched a hole, and this is the hole. You can say this is the address of hole, and WebRTC actually take advantage of this, and it just uh, make a connection through this hole when you are on NAT, because it is a peer-to-peer connection technology. Well, that's all for today. Good to go. Have your day. Thank you.